Number 3 asks us to determine the period of the function below. Now, we know the period is the horizontal length of one complete cycle. So if we look, here is one complete cycle. Whoa, that was way off. But anyway, we can't really determine where that ends. So it's going to be hard for us to determine the period just by looking at it. Now, we do know the period formula is period equals 2 pi over the frequency. And the frequency is the number of complete cycles in a 2 pi span. So the number of complete cycles between 0 and 2 pi. So from 0 to 2 pi, we have 1, 2, 3 complete cycles. So the frequency is 3. So what I can do is I can replace the word frequency with a 3, and this would be my period. Number 4 wants us to determine the equation's amplitude. So we can use this formula. We know the amplitude is equal to the max minus the min divided by 2. So they say the maximum number of hours of daylight is 15.7. Okay, that occurs on June 21st. The minimum hours of daylight is 8.3, so I'm going to plug that in for minimum. That occurs on December 21st. And we're just going to subtract those and divide by 2. So when you subtract those, you get 7.4, and 7.4 divided by 2 is 3.7. So our amplitude is 3.7. Number 5 says that the height of a yo-yo above the ground can be modeled using this equation that we're given right here. All right, in part A, they want us to determine the maximum and minimum heights that the yo-yo reaches above the ground. All right, well, we know that the formula for finding the minimum is just the vertical shift minus the amplitude. So if we look at our formula, this 225 right here, 2.25 is going to give us our vertical shift, and the amplitude is right here in front of the word cosine, 1.75. So all we have to do is just take the vertical shift and subtract the amplitude from it. So that gives us 0.5. Okay, so now to find the maximum is just the vertical shift plus the amplitude. So this time we're going to be adding the amplitude to our vertical shift. So when you add these, you wind up getting 4. So again, the minimum is 0.5 feet, and the maximum is 4 feet. 5b asks how much time does it take for the yo-yo to return to the maximum height for the first time. So they really just want to know how long does it take to complete one cycle. And that's really the definition of the period there. So what we're looking for is our period. So we know the period formula is equal to 2 pi over our frequency. So let's just say that's equal to 2 pi over, well, the frequency in our equation is right here. It's equal to pi. So let's replace frequency with pi. And what's going to happen is the pi on top cancels with the pi on the bottom, so it leaves us with 2. So it takes 2 seconds, that's our unit, for the yo-yo to return to its maximum height for the first time. Number 6 and 7 just really ask us about the shifts of our curve. So if we look at number 6, we really just want to compare this graph to your basic old y equals cosine of x. All right, now this in here helps us with our horizontal shift. And we know that the general format of an equation here would be y equals cosine of x minus your horizontal shift. Now, since this is a positive sign, and the formula follows, a subtraction sign in here, since we know that if you subtract a negative, it gives you a positive, what that means is we must have a negative in front of our 2/3 pi. So really, this right here, the negative 2 pi over 3, that's going to be our horizontal shift. Okay, so negative 2 pi over 3 is going to be our horizontal shift. And what that means is we were shifted 2 pi over 3 units to the left. Okay, with number 7, in order to find our shift, what we have to do is we can't really have a number in front of the x here. See how in number 6 it was a 1 in front of the x? What we need to do is we need to factor this 2 out. So this becomes a little bit, more complicated. But if we were to factor this 2 out, okay, so our frequency is 2. we'd be left with x minus, and then you want to think, well, if I distributed a 2 into what was here, what would leave me with a pi over 2? Well, it's going to be pi over 4, because if you think about it, 2 times pi over 4 would be 2 pi over 4, and doesn't 2 pi over 4, right, 2 over 4 simplify to 1 over 2, which would now match up with this. So really, when we go to talk about our shift here, we already have the subtraction sign in our formula, so this right here, the pi over 4, is going to be our shift. So this right here is being shifted pi over 4 units to the right. So now they say, what is the horizontal shift? So it's really just this, pi over 4. Number 8 says, given that the volume of soda in a 12-ounce bottle from a factory varies normally with a mean of 12.2 ounces and a standard deviation of 0.6 ounces, they want us to determine the probability that a bottle chosen at random would have a volume in part A greater than 13 ounces. Okay, so if we want to figure that out, the first thing we have to do is we have to figure out the z-score that goes along with 13 ounces. So we know that the z-score is equal to the value minus the mean over the standard deviation. So in part A, our value is 13. Our mean is 12.2. And our standard deviation is 0.6. So that's equal to approximately 1.3333, right? Just keeps repeating. So if we want to figure out the probability that the volume is greater than 13 ounces, whenever we see greater than, what we need to do is, well, first in your calculator, you're going to go to normal CDF. And whenever we see greater than, what we're going to do is we're going to use our z-score here as our lower bound, and we want to include everything greater than that, so everything up to positive infinity. So we're just really using a really big number here, so usually I use positive 9999. And when you plug that in a calculator, it gives you 0.0912. Okay, so there's about a 9.12% chance that the volume is greater than 13 ounces. Part B wants us to find the probability that the volume would be less than 11 ounces. So let's go ahead and do the same thing. Let's find the z-score that goes along with 11. So we'll do value of 11 minus the mean of 12.2 divided by the standard deviation of 0.6, and that's actually equal to exactly -2. Now, because they want the probability that the volume is less than 11 ounces, this is going to be our upper bound, and the lower bound is going to be a number that represents pretty much negative infinity, a really small number. So again, whenever you see less than, when you go in your calculator to normal CDF, you're going to use a really small number like -9999, and you're going to go up to the z-score. And in this case, I got 0.0228. Okay, and they didn't say to change it to a percent, so you could just leave it like that, but that is approximately 2.28%. And finally, letter C wants us to find the probability that the volume is between 11.5 and 12.5. So when they say between, you actually have to find two z-scores. So let's first find the z-score that goes along with 11.5. And then when we're done, we're going to have to find the z-score that goes along with 12.5. All right, so again, value minus mean divided by the standard deviation, and that gives us approximately 1.1667. The z-score that goes along with 12.5 would be our value of 12.5 minus the mean of 12.2 divided by the standard deviation of 0.6, and that gives us exactly 0.5. So since we want to find the probability that it's between these two, when we go to normal CDF, we're going to use our smaller number as the lower bound, so negative 1.1667, and we're going to use the bigger number as the upper bound, and when you hit enter, that gives us approximately 0.5698. So approximately 56.98%, almost 57%.